The new EZ-IO. You guys ready for it? You bet. Yeah. There it is. Remember that? Many of you may or may not recognize that. We're a distributor, as Johan I think said earlier, from the US, and we've been repping the EZ-IO product for a lot of years, way back before they even used them, in fact, when their controllers were white, like this one. And they only made one, by the way, one controller. It was like Henry Ford said, you could have any controller you want as long as it was white. And that was not even programmable, that was configurable with a browser, and there was drop-down menus, and you could make it, the loops do this and do that, there was and statements and stuff. So it's been an evolution, it's been a pleasure to work with them. We rep a lot of different vendors. I can tell you that the company I work for, EZ-IO by far, is right up there at the very top. It's easy to spot innovation when you see it. And it's in your face like that every day. So these guys are definitely blazing the trail, great people too, homegrown, real world people. So it's a pleasure for us. Mike had asked us, we, as a distributor in the States, we have a lot of experience working with the different brands and vendors and products. And we have an entire engineering house, part of our company, and building applications and stuff and assisting our integrators get started and start working with new product is something that we've done for a lot of years and have a lot of experience. So when EZ-IO started to put their toe in the water and actually build unitary controllers, which build out the product line, so now it's not just big plant controllers that do all this stuff, but actually unitary and take the world of EZ-IO down to small units, the fan coils, the rooftops, the VAV boxes, the heat pumps. Applications are going to be key for that, so we wanted to get involved and assist in that in any way. And it really is a fairy tale. For us, it's a fairy tale because we eat, breathe, and sleep EZ-IO and love Sedona and not only GPL programming, but line programming, building kits and whatnot, and taking that to the VAV boxes is literally the next logical thing here. So the need, VAV boxes are everywhere in the States. I know VRF has a lot of pressure on systems now for variable refrigerant systems there, the packaged Mitsubishis and whatnot. That's been making great strides in our industry, but now I'm happy to hear that they're starting to lose traction because of all the refrigerant piping that they're running in buildings and this and that becoming a potential indoor hazard. So VAV is going to remain strong and is back in the forefront in the States. So it's everywhere. There's not only new systems, but thousands of existing systems out there that are not even DEC. They might be pneumatic. We have over in the States, we have a lot of old buildings in the East where I'm from. And VVT, variable volume and temperature, those are the simple damper zoning systems. The systems that don't actually control to airflow, they just simply modulate a damper based on the temperature and zone. It's basically like a cheap poor man's VAV system. Those are very popular in the States. Have been in the past and even now more. They're becoming even more popular because of the rooftop that you bolt those to is not a VAV variable air volume rooftop. It's just a generic two-stage heat, two-stage cool rooftop with a damper, bypass damper. So it's really a cheap way to put a system in. So currently today, the VAV app that we're building is today, at this point it's VAV, but we're going to take it to the next level even and have a couple of backend variables, objects that you can manipulate backend in Sedona to make it VVT. So out of the box, it will be factory flashed VAV, but you can manipulate a couple of variables and boom, now it's VVT. So we wanted to definitely cover that as well. Like I said, VVT and VAV are the single largest volume of DEC controller sold by OEMs today, right? If you think of all the big players that are out there, the Johnsons, the Honeywells, the Siemens, the Inventus, they make DEC hardware of every different flavor, but no one will argue when you ask any one of their product managers, the VAV is the highest sold volume controller. So it makes perfect sense for EZ-IO to start there because that's where they're going to sell the most of them, right? There's a hell of a lot, because jobs typically have 200-300 VAV boxes. That's not uncommon. They're everywhere. Like I said, new systems are being installed today by the thousands, and huge retrofit opportunities exist due to aging existing legacy systems. Like I said, there's tons of pneumatic systems out there. There's tons of old DDC systems. Train has had a large, big installed base in the States, and using their old legacy tracer systems and whatnot. And when integrators always ask me, they say, hey, I got this system out there that I want to replace. Can I use the existing COM bus wire? Right? And I always tell them, well, how the hell do I know? I have no idea. Is the bus working now? And I always tell them, look, if you're planning to put backnet over that wire, my question, you want to know is the bus an RS-45 compliant cable, the existing bus? I said, I have no idea. Bottom line is you have to take the number off of the cable, go look it up, find the electrical specifications for that cable, see if it meets the RS-45 standard, and then make sure that it doesn't have any shorts or nicks in it. Right? That's the old way approach. But now that we've got Wi-Fi, I'm just going to tell them what bus. You're going to do Wi-Fi. The heck with that bus. You've eliminated the liability of trying to reuse that bus. And by the way, your throughput, your data throughput's going to be huge. And it's live programming and all those kind of accoutrements come with that. So, like I said, and then of course for pneumatic retrofits, as long as there's power up there, if it's a fan-powered box or electric reheat box, there's going to be power there, juice there. I think of all the hospitals that are out there that are pneumatic, and to Mike's point, retrofitting in existing buildings today, if you have to pull a new bus, that's a major upset, right? If you got electricians opening every third ceiling tile and pulling cables here, there, and everywhere, sometimes that cannot be done during normal business hours. So now now the job has to be done at night. So now you're paying double time and a half, or whatever it is for the installation staff. You go to a wireless installation, it's one guy, one ceiling tile, in that spot where the VAV is, and he moves on to the next one. And as he's going along and replacing these boxes, the network is meshing and connecting, and at the front end they're showing up and populating. That's the way of the future for retrofits. That's here today now. It's not the way of the future. It's now. So again, VVT systems are hugely popular in the U.S. So that will be a key piece of our applications. And traditional retrofits require a new bus, as I said. And the EasyIO, the Wi-Fi EasyIO solves all of these traditional issues. Every one of those. So what's it do? Well, it's fully programmable, application-specific, backnet-enabled VAV. That's a mouthful. So application-specific, typically to us that used to mean that we bought the controller from a manufacturer, it came out of the box, I powered it up, it had an application in it, and it did VAV, rooftop, tank, whatever. And traditionally that was fixed. We were stuck with what was in it. So whatever the manufacturer put in it, I was stuck with. But application-specific does have its benefits. One, I don't need to flash it. If I pull it out of the box and I need to get the system online or sell it as an over-the-counter product to a guy if he wants to go replace that pneumatic box, if he wires it up correctly and puts the correct sensors on it and stuff, that thing should start working as soon as he powers it up, okay? So that's really key, and that's what we want. That's a very strong benefit to that. But on those jobs where I've got some crazy engineer, spec engineer who wants me to do some crazy stuff, this, that, or the other thing, then I want to be able to program. Right? I want to be able to get under the hood and do this, that, or the other thing. Or maybe I want to take it and do things that, for the extra I/O or whatever, that are not intended to do out of the box. That's where fully programmable really has its power. And then of course, everyone wants backnet. I'm a big TCOM guy, but I do, backnet does have its place, but I think TCOM is an extremely powerful argument to that. But the beauty of that is, as you know, with anything you program in EasyIO, if you program it using backnet objects and stuff, those are Sedona objects. So you can now use backnet or TCOM Sedona, or both. You're not kind of stuck with using either or this or that. So like I said, the intent here is for this core app, this kind of app that we're thinking is going to be the starting of this, the foundation of all this, will be factory flash, so that when you get it, pull it out of the box, it's ready to go. Wi-Fi, as Wim said, is Wi-Fi or Cat5 Ethernet, and daisy chain capable, so you can exceed that 300-foot limit of Cat5 if you want to hardwire it. And probably on new jobs, I can tell you right now, I can see that people would be, if it's a new job coming out of the ground, new steel, new concrete, yeah, they'll probably pull Cat5. Because that way they know it's their bus, it's secure, and this and that, or that argument there is, we can argue that 10 different ways, but they probably will pull wire to it, but the beauty of it is you have choices. And multi-protocol, as I said, backend IP out of the box, Sedona SOX, TCOM, and P2P enabled. So many of you may not know what the point-to-point protocol is, but that's those are a collection of some kits and objects that allow the EasyIO product to talk to each other on their own subnet. And we built in a bunch of P2P widgets or objects in there so that you can not only balance the box locally from your phone, your portable mobile phone, but you can balance it through BACnet. And then there's global commands you can pass to the controllers that they simply listen for. There's literally no configuration for the global commands. One is like drive all boxes to max, morning warm up, occupancy command, HVAC mode, all those things. The application is simply listening to those commands across that P2P network. And there's one base address you can set. So if you have, let's say, 10 air handlers, all I'd have to do is set one base address for that group of VADs, and they'll all now be associated with one air handler. And then the next group is associated with the next air handler, et cetera, et cetera. Wi-Fi balancing via smartphone. So that's huge, because right now all the OEM boxes that are out there today typically have to be balanced with either a separate tool or a special wall module, their proprietary wall module that you have to buy. That's usually $70, $80, and that it's a temperature sensor, but also it has like some sort of menu. You can get into a menu, you can balance the box that way. Well, being able to balance it through your phone, the balancer itself is huge, because now I can use any wall module I want. I don't have to buy a $70 or $80 wall module. I can use an existing wall module, right? If it's retrofit, usually I can reuse the existing wall module, or if an architect has a specific theme he wants to keep with the architectural sensors and stuff in the space. Bottom line is, it opens it up. We can do anything we want with the wall modules now, because we're not stuck balancing it through a wall module. And then as Lynn's going to tell you later, that he's going to talk about the Wi-Fi wall modules that EasyIO is developing and bringing to the space. So that's another key piece of this. So as I said, it's application specific or factory flashed out of the box, yet fully programmable live via the CPT or Workbench. If you want to use Workbench, it's your choice. Go anywhere in the building, live via Wi-Fi, and make programming changes. Well, that's huge, right? Because you could have if you've ever been on a job and actually started up a job, and, rolled up your sleeves. These guys are coming at you all the time. Hey, can you start air handlers such and such, or can you override the chiller plan, or such and such is having a problem here. And usually you have to run around and plug into controllers, and you're trying to kind of put out all the fires all day long. Well, with Wi-Fi and live programming and live network, you literally can walk anywhere in the building with a laptop, Wi-Fi, and just access any one of those controllers and make changes live on the fly. So it's something that you just can't do. It's unprecedented in our industry. So sold individually, so the controller, they're obviously selling the controllers as an individual VAV box controller, but they're also going to bundle it with an industry-recognized high-quality Belimo direct couple actuator. So at a price that is right on the target for the industry, for VAV with an actuator. Installation flexibility with two-piece VAV plus direct couple actuator bundle. Ideal for VAVs and VVT dampers. I can't tell you how many times we have had problems with manufacturers' VAV controllers where the VAV actuator is physically mated to it, and you can't remove it. There's no way to uncouple it, and the manufacturers, it just won't fit in the manufacturer's VAV. I mean, that happens all the time, right? And so you have to then, you would be forced to buy the manufacturer's different controller that doesn't have an actuator, get the actuator separate, so you're losing that bundle, the economies of scale of bundling it, right? Well, in this way, their approach is they're simply going to start with a two-piece bundle right off the kicker. So that is going to solve a tremendous amount of installation problems down the road. And then secondly, I can tell you for the VVT systems where it's just a damper, VAV boxes typically have a flat surface and maybe even an enclosure to mount the VAV controller and the actuator in. So it's made to take a controller. A VVT system or a simple damper, that is just a piece of round duct with a shaft sticking out of it. And I have seen, we've had lots of problems where manufacturers have tried to mount that single piece VAV controller that has the factory mounted actuator to the shaft of that thing. And then what? There's nowhere to secure the other side of the controller, right? So you got this controller like dangling off of the round duct, and that just doesn't work. 6 months later, you're back there, and all the actuators are breaking, the gears are wearing out, or whatever it is. So this way, the actuator can actually be turned horizontally, to match the duct, and secured with that one retaining screw like it was intended. And then you mount your controller something next to it, or on the steel or grid, whatever it is. So why is this better? Well, traditional application-specific VAVs from other OEMs lack universality with limited features. Other OEM VAVs require the $70+ OEM wall module to balance it, driving up the cost of the VAV installation and limiting architectural wall module choices. Traditional application-specific VAVs are not programmable and have limited configurations. Typically, they're just, you can manipulate some of the back-end objects or something to tell it has CO2 or this and that, but it's not fully configurable like this is. And they only have one networking choice of protocol, right? You buy it long or back-end. That's it. So their box solves all of these. Richly featured universal factory loaded application in the VAV. We like to think we've covered all the bases there. You can either tweak it, use it as is, tweak it, or completely blow it out and put your own in, which is highly encouraged as you build your own libraries. But this gives you the starting point for sure. Fully programmable live, no downloads, CPT or Workbench. Choice of any low-cost wall module of your liking. We're talking an $8 wall module with a ±2 knob on it, bypass. That's typical. Balancing with your smartphone via the built-in dashboards, as Lynn had told you, or via BACnet, Sedona, or TCOM, or any one of those. And so what does it do? I guess I would encourage you to come and see we're going to have a deep dive tech session later on. I'm getting flagged here that we're out of time. We've got to go to our tour. But basically it has all of the functions and features you would typically ever come up against, right? You've got CO2, you've got the ability to take a local occupancy sensor, you've got obviously your CFM flow set points in there, morning warm-up sequences, everything. A VAV is a VAV is a VAV. You've got modulating, reheat, staged, normally open, normally closed radiation, discharger, high limit if you have electric heat. Series fan control is typical, and we're also adding parallel fan control and then modulating parallel fan control. Flow sensor zero calibration, balanced via standard ASHRAE K factor, right? That's the standard universal way of balancing. Low flow alarm, that's great for the EMS, and typically the air handler monitors that, so that the air handler can maintain a lower static other than what it was set for, and then ratchet up as it gets low flow alarms for one or more boxes to then meet that box, and then later on it can bank back down again to conserve more energy. Those are all built with two-piece actuator. Look at that. What a nightmare that is. So there you are. That's a real-world two-piece actuator would solve that. Just notice how these guys, I don't know if it's clear, but notice how they bent the sheet metal down to get the controller to mount, right? And then they mounted a piece of wood to the left, to the right. I mean, this is beautiful. As soon as when I saw some of these pictures cross my desk, I said, oh, I know what I'm doing with those. So that's all avoided when you go with a two-piece actuator bundle right out of the box. This is a live, we have ours integrated. We've been testing it, thoroughly testing it at our office. And our office is a VVT zoning system, so the duct static is all over the place. And that is like the ideal test ground to test this application on, because we built a special kit, a special PID and a kit. And the PID is designed so that it limits actuator hunting, right? It's the worst thing for a VAV box is for the actuator to constantly be on the move. A, you'll wear out the actuator, and B, your flow, because flows are going to be turbulent. If they didn't give you the 4 straight duct runs in front of the box, you'd have turbulent inlet. Or if the static's not totally maintained dead on from the air handler, it could be static can go up and down. And last thing you want is that actuator constantly be chasing that, right? You want it to get within the control, the set point, CFM flow set point, and then hold, right? Stop hunting around. So we built a special PID that has those features in it. And the best thing is we're testing it live. We have it connected physically to our air system at our office, where the static goes up and down all the time because it's a zoning system, right? As dampers open up and stuff, and the air handler does not make any static. So if you notice the green line there is the damper position, you notice that as the flow goes all over the place, the damper is not like constantly trying to jump around and chase it. And you can see that our flow is within that dead band, by the way, is adjustable based on a percentage of the flow set point. So it's not like, well, what's the dead band, 20 CFM? Well, that might be good if you're down at minimum. But when you're up at maximum flow set point, which might be 2,000 CFM, maybe I want my dead band a little bigger. Well, in the logic, that dynamically adjusts based on what the setting is. So, and again, easy to understand logic. There's nothing special under the hood here. It's built, 90% of this is built with the standard Tritium Sedona kits, right? The ones, those core kits from Kit Control, or the control kit, I guess. And that's it.